Now, we're going to try to go through this worksheet together. I am using a Jif peanut butter and jar and some French cut green beans to help support my phone so we can do these lovely problems. What we'll do is a few together, and then I'll ask you to pause and try one or two, and then replay the video as you go along, but do it at your own pace. And so you will have the answer key by the time we are done with this video. So first thing, a few vocabulary things as a reminder. When I am talking about the limit from as I approach 1 from the left, or the limit as I approach 1 from the right, or the limit at 1, or the function value at 1, the key is we're focused on 1. Note, common sense wise, but this really bothers people, these numbers on to the left are all below 1 in value. These numbers to the right are all above x equals 1 in value. So when I say from below, it's the same as saying what's on the left side. When I say from above, it's the same as saying what's on the right side. So here's the left side, here's the right side. Put down your own pause. You'll see here's the number, left side, right side, left side, right side. These x's are below, these x's are above. So hopefully that'll help with some vocabulary. Now, when I'm doing the limit as I'm approaching, these are nice horizontal lines, so we're starting out with that so you can see what the number would be. But we are heading from the left side or from below, that is getting larger and larger and larger, and heading towards positive 1. What y value am I heading towards? Well, there's no guess here because the y value is always negative 2. And so we're at negative 2 there. When I'm coming in from above or from the right side over here, just tramping along, again, no guess. I'm always going to be at 2 because this is a horizontal line. Now, what conclusion can we draw from these two? These two, when they are not equal to each other, tell us that the limit does not exist. So it has to be one of those discontinuities that doesn't have a limit. Now, I know if you watched one of the crazy videos that we posted that you could see, they used a no solution set symbol here. This, I don't know of anybody that ever uses that. Any book I've ever read, anything I've ever seen, any notation ever used is D&E for does not exist. Now, function value is what a function value always is. A function value is the y value of the closed circle of the ordered pair. And in this case, the function value is 1. Now, when I look at the picture, this is definitely what we classify as a jump. Why do we classify it as a jump? Because the left y value is a real number and does not equal the y right value, which is a real number. Notice these are both real numbers. These numbers are different values, and so we classify it as a jump. So that's problem 1. Now let me move my peanut butter jar over a little. And so now you can see problem 2. Now in problem 2, we're going to ask about the limit as x approaches 2 left, x approaches 2 right, x approaches 2, and the function value once again. If I were to put my paw down, that's where x equals 2. Here is the left side, here is the right side. Left side, right side. So, when I look at this particular problem, as I'm approaching, This could be, who knows what it could be. It could be a square root function. It could be a cubic function. It could be some kind of a curve. We don't care. But I'm approaching to from below or from the left. Notice that doesn't talk about what y's doing. When I say below, it just means as I approach to, the x's are getting bigger. That's why most people say the left, because you all have trouble with the words below and above. Get over it, because your college professors will use them. So now, as I approach, let's say I'm at 1.99999999999999999. I'm getting awfully darn close to a y value of 3. So I would say that the limit as x approaches 2 from the left of f of x is 3, or the limit of f of x as x approaches 2 from the left or below is 3. People read them both ways. Now, when I come from this particular side, yes, there should be an open circle there since we put a closed one there. But, just deal with what Mr. Hadd and I had to do. He did the best he could to put in some open circles. My apologies. The big mistake made here is, what is that ordered pair? If that ordered pair existed, it's not 2, it's 2, 0. So, as x comes from the right or from above, as I'm approaching, my y values are negative, like negative 0.1, as I approach, as I come in and I say, I didn't want to say the y value. As I approach and I'm saying 2.0, 2.01, 2.0000001, it looks pretty much like I'm going to land on 0 if I were allowed. But I'm not allowed to. Once again, these two numbers are not equal. And since this is a real number and this is a real number, this is as I approach from the left, as I approach from the right, they're not equal. This is classified as a jump. The limit does not exist. It's broken. The function value does exist. See the cute little closed circle? It's 3. Like the function value helped us do anything. Like in your first video that I told you to watch, function value is only useful in showing something is continuous. Now, problem 3. Note there is no ordered pair on there and there's not a hole. So this graph, we just go ahead and put your dot at 3. I'm not going to put it on this because this is my original that I'm teaching from, and I don't want to have to print out another one later in case I need to use it for something. But go ahead and put your dot there, because if it is not listed as an open circle, it's a closed circle. So nice and continuous. So what's going on? Here is below 3. Here is above 3 over here. Below, above, left, right. And as I'm approaching and I'm coming up, I don't get 2, but I'm almost 1 when I get close to 3. So supposedly, what if I'm 2.9999999? Maybe this y value is 0.999999999. Anyway, pretty close to 1. As I'm approaching from above or from the right, what's happening? We see the y values are getting smaller. They're like 1.1, 1.01, 1.01, 1.000001. We see we get a 1. When these two are both real numbers and they're equal to each other, the limit exists. And the limit is equal to their value. Now, the next thing I need to do is a function value here. We've already discussed that if you don't see an open circle and I don't tell you it's a mistake on the graph, we assume that there is a closed circle. So this is 1, at least right now on these. There'll be a time when I tell you you can't make that assumption, but I told you to assume that for this paper. So now we have, these are both 1. What happens when the limit equals the function value? We say that the function is continuous. This is the definition of continuity. You have a function value, you have a limit, and they're equal. Problem 4. And in problem 4, again, it's at 0, so please put a closed dot right here. Please put a closed dot right there. And when we come in, now this is up to you to guesstimate. Some of you are going to tell me 12.5 for the y value. Some of you are going to tell me 13, some 12. I don't care. Just get it in the vicinity. But we can see here is the left side, here is the right side. And as I'm approaching from the left or from below, the y value looks like it's approaching 12.5. On this side, as I get nearer and nearer and nearer from the right or from above the x values, I'm also going to 12.5. Because these two are equal, the limit exists. And so the limit is the value of these two. Again, that is a function value. I told you to put it on there, 12.5. And since the limit exists, the function value exists, and they're equal, we say the function is continuous. I pulled the wrong paper up. This was supposed to say 0. Sorry, guys. I just grabbed the wrong paper. So, my apologies. Okay. Did I do these? I can't find my number 4, so we'll change this to number 4. Just live with it. This is what happens in live presentations. All right. So now, for number 5, whom I just used, I'll have to come over here and get it. So we want to do the limit as x approaches 1 from the left of f of x, and the limit as x approaches -1 from the right of f of x, and the limit as x approaches -1 of f of x, and f of -1. All right, so when we're looking at this particular problem, note there is indeed a hole here at 1. This is the left, this is the right, this is below, this is above. I do not see an ordered pair anywhere. And as I'm getting closer and closer and closer and closer to x equals -1, y is getting closer and closer to the value of 0. As I'm getting closer and closer and closer and closer to -1 from above or the right, the y value is getting closer to 0. Since these two are equal, we have a limit, but I do not have a function value. And you can go u and d, but please do not write d and e. It's undefined. D and e results to some kind of equation that we've written, which would be does not exist. Now, what happens when you have a limit? So you actually have a limit. These two are the same numbers, but there is no function value. That's how we define hole or point discontinuity. Okay. Problem 6. Now I'm battling with the sun now. Again, we tried to fix this. Please note this is an open circle. This is a closed circle. Open, closed, open, closed. Folks, we do the best we can with the technology that Bloom High School has. You all know that, so bear with us. So notice this is a nice, cute little oblique line that's got a hole in it. And so, I've got nice, cute little ordered pairs as this is the left side, this is the right side, this is below, this is above. And as I'm approaching from the left, getting closer and closer and closer to 1, it looks like Y is getting closer and closer to 1 also. As my X's get smaller and smaller and smaller, approaching their way to the number 1 value for X, my Y values are getting smaller and smaller and smaller and approaching 1 also. Notice these are equal. They're both real numbers and they're equal, so I have a limit of 1. So that means near 1 on both sides. If X is near 1 on both sides, Y is near 1. What happens at 1? Again, be careful. This is not the ordered pair 0, 1, but 1, 0. So what is the actual Y value here is 0. Therefore, again, the limit exists. It's important the limit exists. We have a function value, but these turkeys are not equal to each other. And since they're not equal, we call that place, that particular open circle, a hole or a point discontinuity as opposed to a jump when these numbers are not equal and you have broken pieces. Now, let me once again do just a little aside. While we're here, yes, you're looking at my dining room tablecloth. Here's a belt, and in this belt we see, oh look, it's nice and connected everywhere, and just this cute little point's missing right here, this cute little hole. That's a hole. A hole means, look, it's beautiful. There's only one spot where we're not connected. A jump is more like looking at when I give you the, well, I'll do it this way because this is getting hard. Sorry, guys, this is the wrong direction. But it's kind of like I've got this belt buckle and this, and wow, they're not lining up together, but they're separate. This has a Y value different from this Y value. Sorry, I couldn't do it horizontally. My apologies. Okay, again, I got to make do with what I got, folks. Sorry about that. So now, we're getting to some problems to where you should be able to stop the tape and go ahead and try them on your own. So now we're going to approach 1. I want to get through a couple of these before you do that, though. Notice that's a vertical asymptote at 1. This is a horizontal asymptote at -2. This is a horizontal asymptote at 1, just so we can translate the picture. There is no number on the vertical asymptote, so there is no ordered pair at 1. This is the left side of 1. This is the right side of 1. Below the number 1, and these numbers are above the number 1, meaning X values, folks, X values. So, as I approach 1 from the left, oh no, I'm going to hell in a handbasket. I'm heading down to approach Satan. And how do we indicate that even though it's D and E, as in the video we stated? This is a better meaning. This means D and E, but I'm heading to negative infinity. So what happens on this side? Woo! I'm racing up to heaven, going to go meet Jesus. And this direction is positive infinity. Positive infinity does not exist. So this really means D and E, but this is a descriptor of the direction. So D and E, but I'm going to negative infinity. That's what all of that symbol means. D and E, but I'm going to positive infinity. That's what that symbol means. The infinities do not match. So they're not the same infinity. So I have to say D and E. So this helps me with direction, but this is still just broken. It's two separate pieces not going the same way. There is no function value. This is undefined. Now, this is the one that's very popular. On the AP, they will tell you it's called an infinite discontinuity, or it's called a vertical asymptote, but your college professors and your textbook use the word unbounded. That's what I was always taught. But please understand, for AP purposes, many times they say infinite vertical asymptote. They would take unbounded, don't get me wrong. And there's not a multiple choice this year, but yes, yeah, there we are. So now to this next one, which you might want to try on your own, but we'll look at it again anyway, because this is the sheet. Again, left side of 3, right side of 3. These numbers are both x's below, x's above. This is a horizontal asymptote. That is your vertical asymptote. There is no ordered pair there. What happens as I approach from the left? I'm heading up towards Jesus. So that's positive infinity, which means does not exist. What happens from the right? I'm heading up towards Jesus. What does that mean? Positive infinity does not exist, but these infinities are equal. Since they're the same kind of infinity, yes, the limit as I approach 3 does not exist, but it's heading towards positive infinity. There is no ordered pair, so it's undefined. Again, it's classified infinite, vertical asymptote, and unbounded. Pick your favorite. Okay, the last one that will be different will be number 9. Notice I do have a horizontal asymptote. I do have a vertical asymptote at 2. I do have an ordered pair at 2, 1. And so now we want to know the limit as we're approaching 2 from the left. Woo! Going to hell in a handbasket, as my grandmother would have said. And on the other side, we're whooping the same way, so we're heading towards negative infinity. These two mean the limit does not exist, but it's going, the direction of the graph is negative infinity. This says the limit does not exist, but it is heading in the direction of negative infinity. These infinities are equal, so I'm able to write negative infinity there. I do not write D and E. That would be incorrect. Unless on a multiple choice they didn't give you negative infinity as an answer, it would be expected that you would say negative infinity otherwise. The ordered pair is 2, 1. Notice again, the minute I get an infinity involved in the problem, it is infinite, vertical asymptote, or unbounded for its classification. And so now we're going to start some repeats of some things that we're going to do. This one's slightly weird when we're looking at it. You'll notice here is 0, the number we want to approach, left side, right side. These x's are below, these x's are above. This is heading towards negative infinity. This is an open circle. And this is the ordered pair. Well, as I'm heading from the left or below, again, I'm heading in that wonderful direction of going to meet Satan. Over here, as my x's get smaller, my y's are getting smaller, and eventually they're approaching but not equal to negative 1. These two are not equal on many levels. First, this is not a number, and this is. So this is D and E. Yes, I do have the ordered pair. The y value is 1. Now, this one is not really classified as anything because it's made up of an infinite problem and because it's also a jump. So I've coined the name infinite jump. There's no such thing, but what the heck. You know, if we can't have fun with this, life would be too boring. All right, now on to number 11. Notice in number 11 at 0, there is no Open circle indicated there was only one graph, and that was number 2 where we forgot to put it in. So assume for these problems only on this worksheet that means that that's a closed circle. So as I approach, here's the left, here's the right. These x's are below, these x's are above. As I'm approaching 0 from below, what is my y value? It's going to be 0. And when I'm coming from above or from the right, my y's are getting smaller and smaller. They're also 0. These are equal, so the answer is 0. Because that is a closed circle, it's 0. Since these two are equal, I say the graph is continuous. Definition of continuity. Problem 12 is similar to problem number 11 in that I need you, that's understood to be a closed circle for this sheet only, so go ahead and put your dot in. And notice as I come in from the left, I'm landing on 0 for the y. I come in from the right, I'm landing on 0. Notice they're equal, so the limit exists, and the function value is 0. And so we would classify it as continuous. And now, for the final page, and again, at any point, you can pause the video and try these on your own, and I encourage you to do so, because we're doing some review. We'll see, here's the left of 1, here's the right of 1. I see an open circle, I see a closed circle. This is the true function value. This is horizontal, this is oblique. As I'm moving in from the left side, as x gets close to 1, y is going to still stay at that value, -3. As I come in from the right side, my y's are getting smaller, but as x is getting smaller and approaching 1, my y's are dropping down to getting almost -2. Notice these two numbers are real numbers. They are real numbers and they're not equal, so that means we have a jump, just like the belt buckle that doesn't buckle. And so the limit does not exist. Function value doesn't matter except for the point of graphing.